So nice to see you all and warmly welcome. My name is Karin Claesson and I am from the Nobel Prize Outreach here in Stockholm, and we are so happy for this Q&A together with you, supported by our international partners from 3M, ABB, Capgemini, EQT, H2 Green Steel and Scania. And we are going for the next hour to talk about science and on how to be a scientist, something that you all know a great deal of. And as the expert on this, we are so happy to welcome Nobel laureate in chemistry from 2016, Professor Ben Feringa.
My pleasure.
So from rather cold Stockholm, we welcome you very warmly, Professor Ben Feringa. Professor Feringa, you received the Nobel Prize in Chemistry for the design and synthesis of molecular machines. What brought you into science? Was that a clear choice from the very beginning?
That's a great question. First of all, thank you very much for inviting me to this event, and I look forward to the discussion with all the young stars that are with us today. What brought me into science, that was not so obvious maybe, when I was a student or when I was at young age. But realize that I grew up on a farm in a very remote area of the Netherlands, in a small village very close to the German border. And when you are a kid, grow up on a farm with animals, with crops, behind our farm there was wilderness. There is a lot to discover. And I was always eager, I remember as a young child, to discover. And I had 9 brothers and sisters, a big family, and many nephews and nieces and family around and friends. And as a kid, there is plenty of room to discover. And I think, honestly, that is where it all started, I think. And in science, we can elaborate on that later, you cross borders, you go into unknown territory. You want to know, you want to make discoveries. And as I said, I grew up on the German border, and behind us was a bit of wilderness, lot of wilderness. And as a kid, we were going into that wilderness, because it was a real adventure. First of all, crossing the border, illegal of course, and then second, go into the wilderness. And I think that is where it probably all started, I was asking questions. I was reading already as a kid books about adventurers and discoverers. And I can elaborate on that a lot more, because that was, of course, I had no idea what chemistry was or what physics were, but that all started in high school.
Well, thank you. I think, I guess that we can return to some of these aspects in the discussion. Let's invite you in, Hamza. Please unmute yourself and ask the first question to Professor Feringa.
Well, hello there. Hello, Dr. Bernard. It's from my side, it's really an honor to meet you in this session. Thank you all for making this possible. So I'm Hamza Nadafi from Capgemini Engineer in Morocco. I'm a supply chain engineer, and I'm also a PhD student in physicochemical and material engineering. Talking about chemistry, the first question is, as a chemist, normally we are more interested in material, in making a new synthesis, in the creation of new materials. But we are not too much interested in making things move, in putting energy in molecules.
Right.
From your side, how did it end up with you in this very specific field, which is interested in making things move on a molecular scale?
Yeah, this is a really important question. Thank you so much. Yes, indeed. So many people around the world make all kinds of materials. And of course we also, but when I started, as a young scientist with my independent group, I had to apply for grants. And I was working already in the field of catalysis and synthesis. And then there was this possibility to do something on materials. And I thought, wow, would it not be cool if we could do something with molecular information storage? So think about the retinal in your eye, the fact that you can see me and I can see you, is due to these tiny switches in your eye. There are millions of them that make it possible that we can communicate, you know, because these light switches in the eye make it possible that the signal goes to the brain and then we can retrieve information. So I thought, in contrast to normal electronic materials, can we make optical materials? So a piece of plastic that you can write zeros and ones, zeros, 1, 0, 1, but then at the molecular level, just like in your eye. And this is how it all started, with the whole idea of making information storage system. But you realize you switch between 0 and 1, 0, 1, 0, 1, switching back and forth, you have a dynamic or responsive system. And then later on, 10 years later, we discovered, more or less by accident, this is important, yeah, so we had all kinds of dynamic materials already, switching, but then we discovered that one switch was not going back, but it was moving forward. 90 degrees, 90 degrees, and we thought, wow, if it's 180 degrees, maybe we can make a rotary motion. And that was the beginning of our rotary motors and our tiny machines. And why is this so important? Realize your body is full of machines, eh? The fact that I can speak to you, that I can see you, that I can raise my arms, yeah? I can wave at you. All these things are due to molecular machines. There are billions of these machines in your body. Now, when you make a material, when you make a piece of plastic, whatever, a coating for your window, it does not move, eh? We are very good in making materials. But to make something that is moving, like in your body, that is actuating, that can behave like a muscle and so, that is a big challenge. And this is where we think is the importance of the field, of these machines, of all these responsive materials, soft robotics of the future. Yeah, this is why we do this. Going from static to dynamic, just like a living system.
Thank you. And thank you, Hamza, for a great and very relevant question. Peter, please, pop your question.
Thank you, Karin. I would like to begin by expressing my gratitude for the opportunity to speak with you today, Mr. Feringa. I gotta say that reading about your work is truly inspiring, as it shows what marvelous discoveries that can be done with hard work and dedication. So receiving no worries. Receiving the Nobel Prize in Chemistry must have been an incredible experience and a great opportunity to share your work with a big audience. I'm an undergraduate in material science and engineering, but making my studies sound exciting to my friends and family, it sometimes feels like I'm trying to make a brick sound interesting, which is rather difficult. So my question to you is, how do you effectively communicate your work to a broader audience, and specifically people coming from non-science background?
Yeah, this is a very important question. You know, first of all, I go a lot to give lectures for public events, yeah, even in theaters, everywhere. I go to schools. After Stockholm, I established a so-called Feringa Foundation. So we go on tour to schools, to elementary schools, to high schools, etc., and to public events to advocate the importance of science. And yes, you are right. Being a chemist, it's even more difficult, you know. When you are an astronomer, yeah, and you show a nice picture of a black hole, yeah, we all know, or the Hubble telescope, yeah, people are getting quite enthusiastic. But when you talk about chemistry or material science or whatever, yeah, then they might say, oh, this is dangerous, you know, and why are you doing this? Or there can be pollution and so. So I have to make the message very clear indeed that science, discovery, being it chemistry, physics, mathematics, engineering, all these things, material science, is so important for our society, and in particularly also for our sustainable society of the future. And I ask always the people, you know, look around you, yeah? All the goodies we have in modern society would not be there if it was not because of science. Eh? And of course, it's not only because of chemistry, but it's also because chemists work together with industry, work together with engineers, work together with material science. But yeah, I always ask, do you have a smartphone? Yeah, now, always 99% of the people have smartphones. And the students, you cannot believe that there was a world before smartphones. Yes, I'm sure. But it was, yeah, when I was a student, there were no smartphones. But all these fantastic things like a smartphone, your laptop, all these things, of course, there is a lot of fundamental science, but also a lot of development to make the screens, to make all the materials, you know, to make the transistors. And this has been a journey of 50 or 70 years. And so I try to make clear, yeah, why it is so important that we have this fundamental knowledge and that we learn from Mother Nature, but we are not restricted by Mother Nature, and that we can adapt and we can make an antibiotic that can cure you, you know, that we can make an anti-cancer drug, yeah, that might help. And there is a long way to go, but realize there would not be electric cars if John Coudenhove and his colleagues in Japan would not have invented the basic principle of the lithium battery. And you would not power your smartphone either, because we would not have batteries. So this is in the 80s, it's 40 years ago. So I try to use these examples to make clear that people understand, yeah, to the examples from their daily life, why it is so important, you know, that we do this together with our students, together with our young talents, and that we do the discoveries. And this is why we need you, yeah? It's not only the professors and the senior ones. Don't only count on the old guys. Look at the future, what is needed. And there are tremendous opportunities to be creative, to think about how we will build the sustainable world of the future. Because we will need smartphones, we will need electric cars, we will need new drugs. There's a tremendous opportunities to discover.
Thank you, and thank you, Peter, for again a very relevant question. Actually, the core of the outreach branches of the Nobel organization as well, how to communicate science to a broader public.
Yeah, if I may add to that, Corinne,
yes.
I think it is really important that we do these things because, honestly, I would encourage, excuse me, also all the young stars here, take it not for granted that people understand, yeah? Even your mother or your father might not understand. Try to advocate, you know, in layman's terms also the importance of science and knowledge and why it is so important, you know, that we do this. And I think we need everybody there, you know, and I try also to do that together with my students. I think it's really important what this Nobel organization is also doing. Thank you so much.
Thank you. Elsa, please.
Good afternoon, everyone, and good afternoon to Mr. Frinja. It's such an honor to meet you. And I do want to say thank you for not only being this organized, but for you actually taking the time to speak with us today. It's very rewarding to be a part of, to say the least.
My pleasure.
I wanted to ask a question regarding the implementation of your discovery. It is obviously quite groundbreaking research that you conducted. And I was wondering, what do you think the practical implementation of it will be? And what do you hope that it will be? What is your wish for it to be?
Yeah, that is a very good question. Of course, I get this question quite often about practical application. And you know, we do very fundamental science. And then it's a long journey towards, you know, application. Let me once again call the smartphone. When the people were discovering the liquid crystal displays in the early 50s or the transistor in the late 40s, the word smartphone did not exist. Nobody knew that 50 years later we would have smartphones, you know, and it would change the world completely. Now, looking into motors and machines, tiny machines, just to give you an example. What we currently have, build them into polymers, in plastics, yeah, materials. And now we have a piece of plastic that when you switch on the light, it starts to walk on the table. Now, your plastic in your home, yeah, your piece of plastic or your plastic bag does not walk, So we have now a piece of plastic that walks because of these tiny motors. Now you might ask, okay, fine. Why are these professors and these students in your lab playing with it, you know? What is it useful? Now think about the future, about soft robotics, yeah? And we work on this. Soft robotics that can pick up something or that can have biomedical applications. Say artificial skin that can adapt to the environment, you know, sensors. All these kind of things will be important in the future. And this is just an example of where it might make a major impact. I can give you one other example if I have time, and that is smart drugs, pharmaceuticals, medicine. So when you go to a doctor, you want to have a medicine that helps, that does something, that is active. But what we want is medicine, small molecules, like an antibiotic, that is not active, but that we can switch on with a nano switch or a nano motor. And this is what we are doing in the lab. And this is called photopharmacology. So making smart medicine that you can switch on and switch off exactly where it's needed. So you don't get all the nasty side effects. And you know also from the newspapers and the TV that antibiotic resistance is a big problem. So we want to fight antibiotic resistance to make, for instance, antibiotics that you can switch on exactly in your body where it's needed, and then it switches off automatically after, say, 24 hours, no resistance build up. And this is the kind of things, you know, where I think nanotechnology will go, molecular nanotechnology, in the future.
Thank you. And thank you, Elsa, for a great question. Camille.
Hi, goedemiddag, Mr. Feringa. It's an honor to meet you. I remember very well in 2016 when I just started studying in Leiden, in the Netherlands, that you were awarded the Nobel Prize. So it's really nice to get an opportunity to talk to you. I wanted to ask you a question about science in general. So science is sometimes very successful. I think you have seen it, but sometimes also very unsuccessful. Experiments don't work out. Grants are not granted. Usually people talk about highlights, but could you share some of your lowlights of your career and in science and how you handled them?
Lowlights. Thank you for this question, because you are from Les Pays-Bas, the Low Country. So yes, we will talk about the lowlights, not the highlights. So yes, of course, when you are a scientist, you know, and I'm sure you all experience that, yeah, in your early career, you need to stand frustrations and failures, because you can have great ideas, but you also know that a lot of things don't work out because simply we are not smart enough, or the idea is not good enough, or things go wrong. Yes? And so realize this happens, of course, to us also all the time, you know, in our team, in our lab, with our research. And but you should be brave, yeah, and confident, because this is science. If you want to have security, safety in your research, don't become a researcher. Sorry, I'm saying it so bluntly, but there is always this uncertainty, because what happens is you want to go across borders into new unknown territory. We don't know exactly what we will discover, because otherwise it would have been discovered already. And of course, this can be small ideas, but it can also be bigger ideas. Now, it is also about risk-taking, yes? And let me give you 1 or 2 examples. We had discovered this motor, yeah, because something failed with our switches. I was mentioning earlier, you remember? We made a switch and it did not switch back. And initially I said to the student, we discussed and said, oh, forget it, because this is a failure, you know, because it does not work properly, yeah? But then we realized, let's look at it a little bit, what is going on? Let's look at it a bit better. So if you find, yeah, I'm a chemist, you know, and if a student comes to me and says, uh-oh, this is terrible, you know, I should have a red color, yeah, after my chemical reaction, but I got a blue color. Then you have to be very alert, because usually it's a complete failure, but it can also be a major discovery. Yeah, and I tell you, we had a problem in the lab. We are working on catalysis. So you know, the basis of chemistry is making chemical bonds, carbon-carbon bonds. You know that. Even if you are not a chemist, you remember that from high school. Making structures, making chemical bonds. Now, we tried a certain new method that nobody had tried for 20 years. I had several students, you know, that completely said to me, I don't want to work on that topic because it always fails. I know that, you know. 20 years. And then one of the students, yeah, made a failure in the lab in the morning. He took the wrong bottle of solvent. Maybe he had been in the pub, you know, had a nice beer, a nice party with his mates in the lab, and he took the wrong bottle. And the reaction worked fantastic. And after that, in the last 5-6 years, we have many discoveries and many publications, and now we understand why it works. But for 20 years it failed. So you need also a bit of luck, serendipity it's called in science, you know that term. Accidental discoveries. But please look for the unexpected. That's really an advice I can give. First, don't give up too easy, be confident, yeah? You might hit on something very unexpected. And serendipity also plays an important role, of course.
Thank you. Such an important aspect, dealing and even learning from failures and mistakes.
Absolutely, absolutely.
Bruno, please.
First of all, I'd like to thank you Professor Ben, the Nobel Prize organization, and the partners, Kenya, for giving me this opportunity. I am Bruno from Brazil. I'm a medical physics student. I am a physics engineer, and I'm doing my master as well in information technology and healthcare management. And the question that I brought is something that has been puzzling me for quite some time, and it refers to multidisciplinarity.
Yes.
I mean, in order to be a good scientist, sir, in your experience, do you see that is it better to know a lot of things, a lot of small things about everything, or should we just focus on one thing that challenges us the most and then discuss it with other people that are focused on their things as well?
Bruno, thank you so much for this question, because this is a really important question. And I don't know if I can give the right advice, but I would say I'm really happy that I have a solid basis in chemistry. And of course, I got also physics and mathematics, yeah, some engineering, but to have a solid base in chemistry, because that helps me a lot, because my discipline and my main basis is chemistry, of course, yes? And so I would say having a solid basis in one discipline, and then nowadays there is a lot happening at the interdisciplinary areas and between disciplines, etc. But when you know a little bit about everything, it might be very difficult to delve into a problem, especially in science, yeah, where you want to, you know, it's different when you do development work, for instance, in a company or whatever, but when you work in science, certainly, you want to have a solid basis that you say, this is my expertise. And then I have a physics person, a mathematics person, or I have somebody from sociology or so, or ecology, or a medical school that brings in his or her expertise. So I strongly believe in a good foundation, a solid basis. And I tell you why. Because we work now a lot for this smart medicine that I mentioned before. We work a lot together now with the medical people and the cell biologist. Now, I'm not in medical school, but we have very close cooperation with the people in infectious diseases, the heart diseases, and the cancer. Yeah, cancer surgeons. And of course, we get now these challenging questions. Can you help us with this infection? Can you help us with biofilms, you know, for hip implants, all these kind of things, heart problems, heart rhythm. And of course, due to the fact that I understand something about the molecular processes, and we can design molecules, etc., or we can design new imaging techniques to find tumors. This helps us tremendously to work together with cell biologists and with medical people. Yeah. So my argument is, you know, of course, you should be open to other disciplines. You should be able to discuss. You should find for new opportunities, because there are tremendous opportunities. But also build a solid basis where you say, this is my expertise that I bring in, and they have the other expertise. Together we bring a nice team. Let me give you a nice story. I was in a high school, yeah, and there was a girl of 15 years old who asked me a question, yeah, and she said, Professor, it must be fantastic that you got a Nobel Prize. You never have to study again, and you never have to make an exam again. And everybody started laughing, eh? And then I said, look, I just bought the latest cell biology book. Probably you have the same book there. The latest cell biology book, 1,200 pages, and I'm studying cell biology just to learn the language of the biomedical and cell biology people, because we have this strong cooperation, and otherwise I cannot communicate with them. So be open and try to understand each other's language, yeah, and then get this spark, this passion, yeah, this spark for discovery. And together you can do marvelous things. Don't be afraid to learn.
No, indeed. Thank you. Great question, Bruno. Benedict.
Thank you, Karen. Also from my side, thank you so much for your time today, Mr. Feringa. It's an honor to meet you and to be a part of this discussion today. So I'm also Ben. I am currently an undergraduate studying material science in London, and I'm obviously thinking about what I will be doing after graduation. So I wanted to ask you, when you've had to make sort of important decisions that affected your career path or life, such as deciding to go from Shell, working at Shell, back into academia, where you obviously had a very successful career then. How did you go about making those important decisions?
Yeah, that's really interesting, you know, because I have a bit of an unusual career there. Because after my PhD, I was like so many people in Europe, you know, certainly at those days, we were bound to go to a postdoc in the United States. But then I had to go in the army, because in the 80s, yeah, after my PhD, the army was still compulsory in Holland. But then I got a job with Shell, and I accepted that. And Shell was this big, huge, Shell is one of the biggest companies of the world, of course, and they had a giant research laboratories with a lot of fundamental research, you know. You probably heard about Bell Labs and so on, all these big labs where they had to do a lot of fundamental research. And so for me it was like a dream, you know, to go there. And of course I must also admit that it was wonderful to work outside the university for a while and to get an idea about companies, you know, build big multinational. You learn a lot about different aspects, than being in the academic atmosphere. But then I was in Amsterdam in the Central Research Labs in the Netherlands, and then I was in the UK and England in the bioscience labs, so I learned from different disciplines as well. But then after 6 years at Shell, and at that time I didn't have to go in the army anymore, I decided to go back to university. And the main reason was that I wanted to build my own research team. I wanted to work on my own ideas. And I was more interested in fundamental research than in doing innovation, development, and so what you usually do in a company. I had a fantastic time in a company, but I wanted to build my own research and work on my own ideas with students. And I also like teaching a lot. So it has been a delight in the past 25 years to work with a team, you know, guys like you know, young students of all over the world. There are people from 14 different countries in my team, you know, and I enjoy that every day. And that we challenge each other, you know. It's not only my ideas, it's also a lot of the ideas of the students, of course, and we debate and we argue with each other, and we come often up with crazy ideas. We have failures, but that's great, you know. And so the real point is I wanted to build my own research, yeah, my own, how do you call it, research program, work on some very fundamental problems, etc. And so far I have not regretted it any moment. Having said that, my whole career as a chemist, I had always also some projects with industry, you know, to work on some more practical problems. So now at the moment, for instance, we work on sustainable polymers, you know, for paints and coatings, just to give you an idea. Yeah, but working on fundamental problems, bringing the knowledge and the field of knowledge forward, doing discoveries and working, getting inspiration, you know, from a team of young talents, it's really rewarding. And teaching is also nice, you know, to explain, you know, what is the exciting stuff in your field.
Speaking of openness,
yeah,
again, yeah. Thank you so much. Very interesting question. Anisha, please.
Thank you so much, and thank you, Professor Feringa. This is an incredible opportunity, and I'm really grateful to get to hear from you and speak with you today. My name's Anisha, and I'm a third-year medical student at the Yale School of Medicine. So hearing about your plans and your ideas for practical applications have been really incredible and very exciting. As you likely know, in the US and in other countries, there's been an influx of misinformation, yes, especially related to the pandemic, and in the past several years, it's definitely increased. And being a medical student, I've had the chance to experience this and interact with many people who are exposed to this misinformation. I was curious what you feel is the role of scientists, not just in educating and communicating with the public, but also in combating this misinformation. And if you feel that as a Nobel laureate, you also have a role to play in this.
Yeah, Anisha, you are in the United States now, I heard, in Yale. So you have experience, you know, about misinterpretation and about all kinds of complot theories, and science is also only an opinion. We see this also here in Europe, you know, nowadays. And it is amazing. And I honestly, that is also the reason, you know, why the Nobel Foundation here, but also why I go often, you know, have these public events, or when we try to advocate the importance of science, and why I go to public events a lot, also on television and so. So in December, I did on the Dutch television, I was with 2 colleagues, we did the so-called yearly overview of science. So we had an hour on television where we could show and demonstrate what exciting stuff had happened, you know, in science, and how science will bring the world forward. And you get also these questions, you know, and you get confronted with these things. And yeah, the message should be clear, eh? If we want to fly airplanes in the future, how are we going to do that? If we want electric cars, I mentioned already batteries. If we want to have better drugs, you are in the medical. If we want to have health problems with the aging population and so, they don't drop from the air. So we need COVID. I had lengthy discussions about that. And I said, look, because you get all these questions about COVID, oh, this cannot be good because it was developed in 1 year. Come on, it was in the 80s. When Katalin Karikó, you know, and so did the messenger RNA technology, and it took 40 years that we, building up decades, you know, of knowledge, that we could now make a vaccine within a year. And I try to advocate this message and say, look, you can have all kinds of beliefs, and I'm very happy, you know, I respect everybody, but it's better to build things on facts, data, and insight. And I think it is a tremendous duty of the universities, of we as scholars, in particular also you know, as young scholars, to make this clear to everybody. Yeah, please, please, let's look at insights and facts. And of course, we don't know. I always tell them we don't know everything. Yeah, maybe we know for a certain thing. We know a drug. Yeah, it has been extensively tested. It's 95% safe, maybe 99%, but there are always a few cases, you know, where people have a special disease or have their body reacts not good, you know this. You have to be also critical, and say, yes, of course, it will not help for 100% of the people. It might help for 98% of the people, but that does not mean that it's not a good drug, not a good pharmaceutical. And so to bring the message clear, yeah, to the people and to the audience. And yeah, sometimes you get confronted, you know, with this, and you say, I get confronted often, because I'm a chemist. They say to me, this chemistry, physics, so this is also rubbish, you know, yeah, because Mother Nature has done everything and is so good and it's fantastic. Yeah, I say, look, but when I fly to the United States, I fly with a Boeing and not with a bird, because this bird cannot transport 400 people 1,000 kilometers an hour. But we were able to build a Boeing, and then I asked them, do you go on holiday sometimes to the Mediterranean or the Caribbean? How do you get there? Yes, I fly. Now, be happy that we have a plane and we know how to fly it, and that we have a good pilot that's well trained, you know, that knows what he is doing. So I think it's also our duty to bring the message forward, to make clear, because you cannot expect that everybody understands, you know, what scientists are doing and why we need that, and how you develop a new pharmaceutical or a new material or a new fuel for your plane. So I, more than ever, to finish this question, I think this is really important for all of us. The duty of the university goes well beyond just doing science and knowledge, but also bringing the message to the general public. Yeah, and advocate, yeah, and build your opinion on facts and data and insight and knowledge.
Thank you. Such an essential question.
Absolutely.
Really, thank you. Gustav, please.
Yes, thank you. First off, it's really exciting to meet you, Mr. Frinka, and thank you for some really fascinating insights so far. My name is Gustav, and I'm currently finishing my thesis within computer science and AI at EQT and KTH. And my question is very connected to what you mentioned before regarding how our research efforts are best realized.
Right.
So when scientists make such important discoveries, such as yourself, in the form of validated research results, what has, in your experience, been the biggest challenges in converting these research results into the intended applicable real-world use cases, if that is the goal? And a small add-on to that, how do we potentially mitigate those challenges?
Yeah, no, that is always a difficult balance, and because I'm in fundamental science now, you know, I have worked in industry, I know how long it takes, you know, from a discovery to something practical. But you should also realize, and I think this is also the message I try to bring forward, it's not only about doing discoveries that bring, you know, a new medicine or a new material or a sustainable world in the future, you know, like energy carriers or so. Of course, this is tremendously important. But it's also about knowledge, yeah? Advancing the knowledge, the insight, yeah? Realize, you know, that already Newton was thinking about gravity, eh? And many people have for hundreds of years thought about how is it that something drops on the floor. Gravitation, yeah? Einstein, yeah? And still today, when I ask to my colleagues in physics or in theory, yeah, they cannot explain exactly what it is. Yeah, it is the time curve, you know, of space, etc., according to Einstein. But to explain exactly, and I think we still struggle with that. So fundamental insights into very fundamental properties that brings us forward, yeah, that brings knowledge forward. Yeah, me and my colleagues, you know, we have also a big program on the origin of life. Now, if there's one interesting scientific question, you know, that everybody likes, where are we from? Is it from outer planets? Yeah, all these new planets that they discover all the time? Or is it primitive chemistry on the Earth that then evolved into biology, you know, several billions of years ago? I cannot see that there is immediately a practical application if you work on replicators, you know, to mimic the origin of life, primitive replicators. But the knowledge, excuse me, the knowledge about fundamental biology, and that we learn more about how biology works and how cells and how replication, and when things go wrong, when you get cancer, I think we can learn a lot from these fundamental insights. Yes? So we have to keep the balance right. Yeah? On the one hand, very fundamental questions, knowledge, bringing that forward, and on the other hand, looking for opportunities, you know, for society and industry. But your question, yeah, but that is sometimes tough. I also struggle with that sometimes. And of course, I get these questions and so. But, Gustav, believe me, in science, don't be afraid to struggle, you know. I mean, when I go on the bike in the morning to the lab, I think a lot about, okay, what's going on in the lab? And what do I confront my students with? And there might be failures, of course. But of course, we should also enjoy the beautiful discoveries, yeah, that we now and then make. And you make small steps, and that is what science is all about. And yeah, there is this uncertainty, yeah, and failures and whatever. And yeah, if you want to save the world, yeah, you have to be also realistic, yeah. But if you contribute to something that makes a new drug or make something like a new energy carrier or a better insight, how energy can store, like for instance, you know, very fundamental insight, yeah. Or mechanical movement like we do with these artificial muscles. I think this can be tremendously important in the future. So, be brave.
Be brave. Don't be afraid to struggle. Good advices. Hema, please.
Thank you, Karen, and thank you everyone who has made this event possible. Thank you, Professor Feringa. I'm honored to have this opportunity to be able to ask you these questions. I'm Hema, I'm from India, and I'm pursuing research at Corporate Research Center, ABP, in artificial intelligence. And I want to ask this question that research in general can be equal parts exhilarating and equal parts overwhelming. So with looming deadlines, large-scale projects, and huge personal investment in terms of your personal time, your work-life balance, and expectations of the family, how do you suggest that young researchers combat this stress and mental health issues and to keep the motivation high in their fields of research?
Yeah, I know exactly what you are meaning, Realize I was also a student, eh? It's a while ago, sorry, I'm a little bit older now, but I was also a PhD student. And it's really important, to keep a good balance, because you can get very stressed and you feel pressured and whatever. Of course, when you are in science, and at university and whatever, research, you all experience, you need a little bit of pressure, eh? You need to feel also this action that you are working in a team or that you work together with lab mates or so, like we work in a lab or with colleagues, and that you feel a little bit, we do something exciting, and yeah, a bit of stress is fine. But you should also find a good balance, you know. That is to say, also to relax now and then, or go to sports, or go have a party with friends and so. I would strongly advocate that, because it's not good to only work, you know, and only... I tell you one story. When I was a PhD student, you know, I had an American professor here, and he put the bar very high. And of course, I was a young, eager beaver, and I thought, okay, I will go for it. I will make it possible. And he said to me, if you succeed, we will make our colleagues in America jealous. Now, it was a bit too difficult, I tell you. So after 8 months, I had no single success. And I was working harder and harder. This is what you do then, eh? You feel stressed and you work harder and harder. And then I came home, you know, in a weekend, and my mother said, do you eat well? Because you look terrible. Yeah, and I said, no, you know, my research doesn't go well and so. But that was a message, you know, when my mother started asking. And then I took off a week with friends, and we went to Germany, you know, and I think we had a great time, you know, partying and so. And after a week, I came back, very refreshing, yeah. And then within a month, everything worked. It was fantastic, because I had a different mindset, you know. You can also walk, you know, like in an alley, eh? So sometimes it's good, you know, to take a little bit of time off, go to do some sports with friends, have a different mindset, and then you are refreshed, and you get a different angle of perspective, and suddenly it works well. And I can tell you from experience, you know, I had it a couple of times. And when you are young, yeah, you feel the pressure a little bit more, maybe, yeah, because you want to build a career, etc. Honestly, I can give you only advice, one advice here. Follow your talent, yeah, and be confident. Because you are talented and you should be confident. And of course, sometimes things go wrong. But don't get too much upset, you know. Say, okay, I can do it. If it will not be from the left, I will do it from the right in the future. But also, find for yourself this right balance. You don't have to prove yourself everything in the first 1 or 2 years of your PhD, yeah? Or in the first 1 or 2 years of your career. You have a whole life in front of you. But it's always good to have some ideas of yourself, and also don't listen only to the old people. Of course, look for advice. It's good to have open ear and to listen, you know, because people have experience. Yeah, I mean, I've been in this game now for many years. But follow also your own path, and be a bit stubborn and think, okay, I will do it different, yeah? But don't find a good balance in all these aspects.
Thank you. Great and important question, Hema. Rebecca, please.
Hi, I'm Rebecca Donaldson. I did a Master's in Bioengineering, and I currently sit in Applied Science and Consulting at Cambridge Consultants. It's a real privilege to be in conversation with you, and I'm very grateful for the organisers of this event. When trying to solve the kind of largest challenges of our time, such as climate change or antimicrobial resistance you mentioned earlier, kind of cutting-edge technology solutions are often pitted against policy or societal solutions.
Yeah.
I think both are needed. But as a representative of top-tier cutting-edge science, how do you think we should be fostering collaboration between policy, science, and society?
Yeah, this is a very important question, you know, and I'm confronted with that quite often, because you realize we often, from the natural sciences and engineering and medical, we come with technical solutions, of course, which is really important. Eh? If you want to fight antibiotics, infections, you need an antibiotic, you know. You have to understand the biological machinery, and without drugs, without pharmaceuticals, you will not be able to do it. But on the other hand, you also have to look at the social aspects and the human behavior, and especially the politics, because honestly, I don't want to make political statements, but we all know there are also politicians that have not that much inside knowledge, you know, about these kind of things. And so they have opinions about things, you know, and we should be able to tell them what is important, you know, at least giving them the facts without judging. I don't want to judge. I don't want to make political statements. But we can bring the insights, what is needed to build a vaccine, what is needed, yeah, if you get an infection, yeah, to help you, to save your life. And coming back to the point, you know, of the perception and so, and what we should do with other disciplines. Yes, I think the unique opportunity at the universities is that we have all these disciplines. Yeah, and of course it is important that we have social science, psychology, that we have law, all these disciplines that help us, yeah, to bring the message forward, because you can think of something beautiful and you can discover something, but people also need to be convinced to use it. Or they have to change their attitude, because we all know now with this energy business, the energy crisis and so, what helps a lot if people, yeah, change their behavior a little bit, you know. Maybe instead of taking the car all the time, maybe also take public transport or bike or go walking, or maybe fly a little bit less and do something by Zoom like we do now. So there is also to do with the perception and the attitude of people. And this, of course, is not our domain, but it's the domain of social science, etc. And so we have to work together. And the beauty of the university, and I miss that a little bit sometimes, is that we should maybe have some more often discussions, you know, with people in other departments, including between science, the medical school, and the humanities and so. Because I think we can benefit from each other, to inform each other, to learn from each other. Yeah? And I think it's important. And in that respect, I'm more and more convinced that the universities play a really important role in society, more than ever. Trying to be independent. Of course, you cannot be completely independent from your countries or your society. We are living in the world with politics, with economics, with business. But still, we should keep also our own role. Being critical, advancing knowledge and bringing forward insights, knowledge, facts, etc. And I think this is an important role for all the sciences and humanities together. And I would strongly advocate universities take that role and bring the communities together and advocate what you were also just mentioning, you know, how to bring the message forward to society. You cannot do that on your own. You cannot do it as a discipline. You know also from the medical field, yeah, you can make a beautiful discovery in the medical field, but that does not mean that people will immediately accommodate to that. Eh? It takes, you have seen this with the vaccines, yeah? So there is more to it. And I think the universities have a crucial role there. Yeah, and especially the younger people, because you are the future, remind me. Yeah, you have to do it. Yeah, also but together we have to do it, but especially the young people. You will shape the world in the coming 20 years, eh?
No pressure there.
No pressure. No, I put the bar high. Sorry.
No, it is what it is. Definitely. Anouk, please.
Thank you, Karen. And thank you, Professor Feringa, for the opportunity to talk to you today. I'm very grateful for this discussion. And I would like to follow up a bit on Rebecca's question and talk about the ethics of being a scientist. Yeah. And I've studied material science at ETH, and I think to have noticed during my studies that a lot of my colleagues were very focused on their studies, and they were very focused and maybe tended to not spend that much time on questions regarding the environment or philosophical questions or ethical questions. However, I think that one day we will all have an influence on the world, should it only be who we work for or whom we get money from, or what happens with our research results. And I think that this is a topic that hasn't been focused on during our studies a lot. So my question to you would be if you've faced many or some ethical dilemmas during your career, and if once maybe, especially you got the Nobel Prize, if you felt a lot of pressure being a role model for future scientists like us now here.
Yeah, thank you so much for your question. Yeah, to start with the first part about the ethics. Yes, I think that is really important, and I would advocate, that every student, PhD student, whatever at the university should have at least one course or a discussion meetings or whatever in ethics, to be confronted with that, because this is very important. because you will all be role models, and with the academic education, you will show leadership in the future at different levels and whatever. People will listen at you. And yes, of course, we should put the standards high. And I think ethics, you know, how you think about things, you know, with respect to what can we do and what we should not do, and so is really important. So this is all to do with this critical attitude that we have to bring to our students, that we have to train also each other, students amongst each other, you know, that we don't take it for granted. And I think the universities play a crucial role there, and I would advocate strongly, and we send students to ethics courses, etc. Scientific integrity, for instance, is a course that all our students take, yeah? Scientific integrity, and this is also to do with of course, with ethics, etc. And we all know how it goes sometimes in real life, and when money plays a role, then some people get a bit sloppy with ethics. I think we should not compromise. The other thing is about the role model as a model, a Nobel laureate. Yes, I realized, you know, the journalist asked me this question, you know, when I was in Stockholm just after the event, and yeah, you realize this is something extremely special, you know. When you get a Nobel Prize, you realize you are among this very selected group. And of course, many people deserve this, because in science, you know, you work with a team of young people, etc. But only a few get it. And then they asked me, you know, you will be a role model. And I said, yes, I will try to, because one of the things I will do now, besides doing science, and I'm also teaching, I'm teaching classes next week and so to students, but I will also go to, as I mentioned before, I will go to the general public. I want to go to schools to be a role model, to advocate why education, knowledge, research is so important for our future and for society, to raise the level of society, you know, and also to circumvent all these discussions about politics, you know, without content, or about opinions, you know, that we have heard quite often in the past years. So being a role model is sometimes also a little bit difficult, I tell you. I enjoy, I must say, you know, it's great, you know, and I'm extremely honored, of course, and it's great. But realize I'm not a movie star, So often they ask you on television, yeah? And they think you know something now about everything. You will not believe, in the past 3 years, in this COVID period, how often I was called by the television stations. Can you come on television because you are a Nobel laureate, and can you tell us about this government, you know, what they do with these vaccinations? Can you tell about these things, etc.? And I have a time refused, because I said, look, there are many doctors, medical people that are specialists, you know, in vaccination, in infectious diseases, in all these things. Don't ask me, ask the specialist. You have to be a bit careful, because suddenly they think, yeah, you know something about everything. Of course, I'm a chemist. I claim that I know a bit about chemistry, you know. And for the rest, yeah, you have to be a bit careful, So, talking about role models, etc. Yeah, but on the other hand, yeah, I have to give signatures. I have to get. I get accustomed now to have selfies, you know, with hundreds of people. I was in India. I think I just talked with a student from India, yeah, and I was in China, and I had to make hundreds and hundreds of selfies, you know, with the students, which is great, you know, you get accustomed to it. But yeah, being a role model is really great. But it also, I never thought when I was a student, you know, that I ever would be in front of the camera so often, you know. You get accustomed to it. Thanks for the question.
Not a movie star, but a chemist star.
Okay.
Yeah, well, I think that Valentin, do you have a question?
Yes, it's an honor to meet you, Mr. Feringa.
My pleasure.
And I'm very happy to be here. And I do my master studies about machine learning and AI. And I know that the technology that I develop can also be used, for example, for military purposes. Yes. And similar things have happened to other great researchers and scientists. And so I wanted to ask you how you personally deal with that responsibility.
Yeah, honestly, as a chemist, you know, you sometimes, you know, you can also get requests to participate in programs, you know. But when I don't trust it, or when I have this kind of situation, you know, where I would be directly involved in military or in dangerous things or so, I would not accept that. I mean, we have certain standards that we don't want to work on certain things, you know. Having said that, we work now on new materials. And I cannot exclude that once we build these new materials, you know, responsive materials, smart materials, that they will be used once in military, because this is how it goes. Yeah, you cannot take responsibility for all the science, you know, that all the the use of science that in the future maybe other groups will do. Then I would not have a life as a scientist anymore, because yes, I cannot exclude that there will be materials that somebody will pick up sometimes and think, oh, I can use this for this or that application. But I think that is also a matter of rules and government, and so that has to decide, you know, what is tolerated and what is not tolerated. In the European Union, we have strict rules about, for instance, what kind of materials we can use. Yeah, people also sometimes, you know, I cannot deny we can make every drug in the lab if you want. If you want to have LSD or so, we can make it. Yeah. We are a synthetic lab. Yeah. We can make these drugs, and I could be extremely rich. But of course, we don't do that, you know. And if we would ever, I would see that anybody would even come in close to that, you know, I would immediately fire them from the lab, because you have to have certain norms, standards, and ethics, you know. But yes, you cannot deny with your knowledge, and the same holds for your knowledge, you know, when you work on artificial intelligence and computation and so, yeah, you can do also nasty things to the general public, and to our society. So yeah, keep the standards high. That is the only thing I can say. And this is how we also train our students, you know. There are, of course, limitations, things we cannot do. But you cannot, I cannot predict if somebody once will go to use our nanomotor to make a nano robot, you know, and do some nasty things with it. I don't know. Not at this moment, but maybe in the future. But then, of course, we also to think about what rules do we want to implement, you know. What laws do we have? How are we going to use them? Yeah. That's
a dilemma that we can see throughout the Nobel Prize history. Indeed.
Yeah, there's always a dilemma, you know. Yeah. We know the famous case of Haber and Bosch, you know, who developed the fertilizer that feeds now 4 billion people, but also they make all the ammunition, you know, for the armies at those days, for the war. So this is this kind of dilemma, you know, that you and when you do it on purpose, it's a different case, you know, than when you say, look, yeah, I don't know, this scientific development in the future, you know, somebody might misuse it. Yeah, we know DNA technology, yeah, this is everywhere now. But yeah, if some crazy person wants to use it to make a perfect human being, I think this is politics, we should have rules about this. This is ethics, yeah?
That is the perfect final words.
Can I give one more word?
Oh, yes, please.
Okay, if you allow me. Once again, you are all bright stars. I wish you a great future. And please, the best advice I can give you is follow your dreams. Follow your dreams.
Yes, follow your dreams. And I think that the Nobel Prize clearly shows the capacity of humanity, curiosity, persistence, and the pure joy of exploring. And you have as well showed us that. So thank you all for great questions. Thank you, Professor Feringa, for your answers and your reflections on the questions. Very inspiring and engaging. So thank you all, and we wish you a lovely day or night wherever you are on this planet that we call ours. And take care.
Thank you so much.
Thank you so much. Bye.